in situ and ex situ bioremediation. So, considering different bioremediation techniques. So, we know that the location of an accident, the amount of chemicals released, and the duration of the spill impacts the parts of the environment affected in many different ways. And so, the following are considered when employing strategies for the cleanup process. Do the chemicals pose a fire or explosive hazard? Do the chemicals pose a threat to human health, including that of cleanup workers, as we saw in BP Deepwater Horizon spill? Was the chemical released into the environment through a single incident or long-term leakage? Is the contamination at the surface of the soil, below the ground? Does it affect water? And how large is the contamination area? So we have these two processes, ex situ and in situ. Ex situ bioremediation involves removing the chemical materials from the contaminated area to another location for treatment. On the other hand, we have in situ bioremediation, which leaves the contaminated materials in place, and it's preferred because it's less expensive and larger contaminated areas can be treated at one time, and it uses the stimulation of microorganisms in the contaminated soil or water. Focusing on in situ bioremediation, it involves the aerobic degradation methods, which often involve bioventing, which is pumping air or H2O2, hydrogen peroxide, which is an oxidizer, into the contaminated soil. It may be used to add fertilizers to stimulate growth and degrading activities of indigenous bacteria, but it's not always the best solution. It's most effective in sandy soils because it allows microorganisms and fertilizing materials to spread rapidly. Solid clay and dense rocky soils are not typically good, and contamination with chemicals that persist for long periods can take years to clean up. And here's the example of bioventing. So ex situ bioremediation is faster and more effective. So you can kind of break ex situ down into slurry phase and solid phase bioremediation. Slurry phase bioremediation involves moving to another site, mixing the soil with water, fertilizers, and etc. in these large kind of barrels called bioreactors. And it's good for smaller amounts of well-known contaminants, and it involves the stimulation of stimulates the degradation of pollutants. And then on the other hand, we have solid phase bioremediation. It involves composting, as many of us have done in the past. It degrades food and garden waste. And then there's land farming and biopiles. So here's a good chart kind of encompassing both ex situ bioremediation and solid phase ex situ bioremediation, so slurry phase bioremediation and solid phase bioremediation. So here we have an example. We have a leaking drum, contaminated oil soil. So in ex situ, we have to excavate the soil, transfer it to a new place, and that can be done. And once that's done, you can either choose to do slurry phase bioremediation or solid phase bioremediation. So here's a bioreactor. This big, large container which mixes contaminated soil with H2O and oxygen and fertilizers to stimulate microbial degradation of pollutants. On the other hand, we have solid phase bioremediation. You have composting, which I'm sure many of you are familiar with. We have land farming, in which you place soil over this filter, and you could collect this excess contaminant fluid in the bottom. You have this biopile where you spread chemical vapors onto this soil pile. And here's a little bit more detailed image of a biopile.